Hey AP Stat, so today we're going to get into Chapter 3, Describing Relationships. I think this is when things really start to get interesting when we look at relationships between variables. Specifically in this chapter, we're going to be looking at the relationships between quantitative variables, and that's going to start with 3.1 scatter plots, and then we'll get to correlation. So by the end of this section, you should be able to distinguish between explanatory and response variables for quantitative data. You should be able to make a scatter plot to display the relationship between two quantitative variables, describe the direction, form, and strength of a relationship displayed in a scatter plot, and identify unusual features. So that'll be this first video. The second one should be interpret the correlation, understand the basic properties of correlation, including how the correlation is influenced by outliers, and distinguish correlation from causation. So, explanatory and response variables. When we are doing our studies, a lot of times we're looking at the relationship between two variables, we use one variable as a measure, like that we're a lot of times that we're recording our response, the outcome of the study, and a lot of times the explanatory variable is one we help use to predict the response of the other variable. So that's a lot of times the case, but not always. We'll see counters to that where we're just looking at relationships. It's not, we may not have that explanatory response kind of defined early on, but we can come up with that. So the response is, what we're trying to, kind of that outcome. In many studies, the goal is to show that changes in one or more explanatory variables can cause changes in a response variable. However, the explanatory response relationship don't involve direct causation. So we'll get into the next chapter how we can actually use experimental design to establish cause effect. A lot of times we just observe the relationship here. This chapter in of itself, we're just looking at the relationship, not necessarily, potentially, but not necessarily able to establish that cause effect unless we've done good experimental design. So like all the stuff we've done so far, a lot of times a good way to describe to summarize a relationship is with a picture. And so our picture that we're going to use here is a scatter plot. It's going to show us that relationship between the quantitative variables, one on the x-axis and the other on the y-axis. And so we show that in a scatter plot. So you guys have done these before. The process: make the axes. So you have the explanatory, the little capital X there, goes on the horizontal x-axis. The response variable always goes on the y-axis. That's just the default we use. Either variable, so if there is no explanatory variable in a situation, we're just looking at a relationship between data, we can go either way. But if we're going to make a specific prediction of one from another, we tend to put the independent or explanatory variable on our x-axis, the response variable are on our y-axis. Scale the axes appropriately. You do not need to go all the way down to 0, and then plot the individual data values. So it's going to have each individual has two quantities. Each individual reading could represent a different person. It could represent some other entity. Some other, would be whatever the individuals are. You're going to have two quantities for them. One for one variable, one for the other. One's going to be the x coordinate. One's going to be the y coordinate, and that's going to get you a point on the graph. So once we make the graph, we're going to be able to describe that scatter plot. So you're going to get all those dots. To describe the scatter plot, we're going to use a similar strategy where we're going to look for patterns and departures from those patterns in the data. And so there are a few features that we'll look to describe with those. So we're going to look for the direction of the association, if there is one, if there is some sort of pattern to how the scatter plot, do the values tend to go up, do they tend to go down, and so on. So if they have a positive association, if they tend to go up, basically if higher values of x tend to go with higher values of y, and lower values of x tend to go with lower values of y. The negative association, if it's kind of sloping downward, is if lower values of x go with, higher values of x go with lower values of y, right? That negative association, and if lower values of x go with higher values of y. And then we have no association if knowing one value doesn't help us at all in predicting the other. So that's one thing we want to look at, is that pattern. We want to look at the direction of the association. And so here's some examples of some graphs. We see that first one here is kind of going upward a bit at an angle. Higher than average x's go with higher than average y's. You know, if the point's over here on the right side of the graph, it's more likely to be higher. If it's lower than average x, tend to be a lower than average y. So that's a positive association. The next one coming down, a negative association. And the last one, no association. So that's one thing we can describe in a scatter plot, but there are other things as well. So that's kind of like the shape I don't know, in some ways, to the one variable, the graphs we used to thing. You know, what's going on. Yeah, a little bit. There's other features to it too. But when we describe a scatter plot, similar to how we had shape, center, and spread before, now we want to make sure we describe the direction of the relationship. We want to describe the form. So this is also kind of part of, I don't know, I guess, shape. It's yeah. It's three things. It doesn't line up perfectly. So the form, does it appear to be a linear or a nonlinear form? Is it curving? What type of pattern do you see there? And then we also can describe the strength. So we used to have shape, center, and spread. Now we've got direction, form, and strength. And so is it a line? Is it increasing? Do certain values tend to go larger values of x tend to go with larger values of y, and then how strong is that relationship? Is it fitting that line or whatever that form is really well, or is it kind of weak and messy? And so that's kind of like, maybe almost you can liken that to spread before. And the last thing, kind of similar to outliers, are there any unusual features? Are there any other outliers? Right, there can be outliers in a scatter plot, and outliers in a scatter plot, we'll get back to this, but are a bit different, but yeah, the same idea, things that don't follow the pattern. So be cautious when describing the associations shown in a scatter plot. Write it in context of the problems. This means that you need both variable names in your description. So if we are describing a scatter plot here, we're looking at the association between pretend taking SAT and the mean math score, and this is for the states. So if we're going to describe this relationship, we want to cover all those things. We want to cover form, direction, strength, any unusual features maybe, and then make sure we get context in there. So here's their description of this. This is a moderately strong negative curved relationship between, so moderately strong, it's not a perfect line, but it's not real messy either. Negative, it's going down. We kind of see a little bit of at higher values of x go with higher values, lower values of y. So it's negative, and realize it doesn't have to be linear to be negative. You can have a curved and negative relationship, and that's kind of what's going on here. They see a bit of a curved relationship. It's not much, and we'll look at kind of how you can make that even more clear, but they are seeing a bit of a curved negative relationship between, and then they get the context in there, percent of students in the state who take the SAT and the mean math SAT math score. And then they describe an unusual feature here, the fact that there are kind of two clusters. There's like a little gap here in the middle, and then there's this other little cluster here. And then they describe possible outliers that fall outside of the overall pattern. I know this one's a little weird, right? This point doesn't quite fit the rest of those, and this one's maybe a little bit weird. What's weird about this one, right? And so it's not that it's like this point right here especially, it's not the biggest x, it's not the biggest y, it's not the smallest x or smallest y. But that particular x value, that particular percent taking the SAT, we had a really low y value compared to like the rest of the pattern, what we would expect. And then this one as well, we have a very high percentage taking the SAT, but a relatively low or a very low math score on that. We would have not predicted that. We would have predicted something up here. So something far away from predicted is what we're looking for with outliers. And then they go through here. Yeah. So we made sure we covered the strength by describing it as moderately strong. You could have very strong, weak, weak to moderate. There's a bunch of different ways you can describe it. We'll actually get a better way of describing strength with correlation eventually. But they describe the direction as negative, and they describe the form as curved. And then we have our unusual features. They describe the two clusters, and then of course we got context in there. as well. So that's hopefully you're good with that, making the scatter plots, taking each data value, plotting its x coordinate, y coordinate, and then describing form, direction, and strength. But that's the first bit for section 3.1.